Assalamualaikum and greeting everyone. Welcome to my final year project presentation. I am Wano Sahira binti Warasli, final year student of Bachelor of Science Honours Biology. The title of my FYP is The Potential of Matured Pandan Leaf as a Source Chlorophyll for Natural Food Colorants. I am supervised by my lecturer, Ms. Nur Lailatul Wahidah binti Musa. This is the content of my presentation. First, let's begin with Chapter 1, Introduction, which consists of background of study, problem statement, significance of study, and objective of study. Food coloring is any dye, pigment, or substance authorized to be used in meals. It is play an important role in changing the shades of meals, which can enhance the appearance of foods. Natural and synthetic food coloring are the two types of food coloring available. Natural meals coloring originate from a huge variety of assets like vegetables, fruits, plants, minerals, and also herbal, while synthetic meals colors are fabricated from the coal tar. Although artificial colors have numerous benefits, they also contain a number of hazardous compounds that have been related to health issues. Many customers prefer to choose foods that include natural colorants since they are more safer. By introducing an environmentally safe pigments into the industry as a food colorant, it will reduce the hazardness to health issue. Due to this fact, the initiative to invent a solution of natural food colorants by using pigments from plants. Natural food colors are a highly quality food coloring that can be used in order to replace the synthetic food colorants. Besides, natural food colorants also gaining more attention day by day as they offer a lot of advantages and their presence brings no harm to the consumer. The natural food coloring was recognized to increase the nutritional value of the foods. Next, we move on to the objective of this study. There are three objectives, which is the first one is to determine the amount of chlorophyll contents extract from matured pandan leaf by using different type of solvent. Number two is to determine the presence of carotenoids in pandan leaf. The third one is to determine the stability of pandan leaf chlorophyll. Next, we move on to Chapter 2, which is literature review. Food colorant is any dye, pigment, or material that is applied to food items, whether it is solid or liquid, which is to give the desired color. Food requires the addition of color to make the food more appealing. Besides, it also gives information so that customers can easily identify the foods they want. Second one is pandan tree. The scientific name of pandan is Pandanus amarylifolius. Pandan is a tropical herb that grows abundantly in Southeast Asia. It is known as fragrant plant in Chinese because of its unique sweet scent, and it is palm tree-like, which is varieties have long, thin, pointed, and also bright green leaf. Pandan also high in nutrients and antioxidants. One of the most important molecules for plant activity is a pigment. Plant pigments are made up of variety of substances including porphyrins, carotenoids, anthocyanins, chlorophylls, and also betalains. The wavelength of lights that reflect determine the color that the pigments will appear to the eye. Chlorophyll is required for photosynthesis, which makes the energy of light available to plants. Chloroplast molecules are specifically located in and around the optical system embedded in the thylakoid membrane of chloroplast. Numerous carotenoids are prevalent in the tissues of green plants, but due to the presence of other natural colorants such as chlorophylls, their color is generally obscure. Carotenoid molecules can generate norisopenoids with strong aromatic characteristics. Extraction is the first step in separating the natural substance of interest from the basic substance. The selection of solvents should take into account selectivity, solubility, cost, and also safety. Natural salts have high potential as a natural food colorant. This is because the color produced by the natural dyes and pigments are very vibrant. The natural dyes neither contain harmful chemicals or carcinogenic components. Next, we move on to Chapter 3, which is methodology. First parameter is determination the amount of chlorophyll content. In order to achieve this parameter, the Pandan leaf was extracted by using three types of solvent, which is acetone, ethanol, and also methanol. After that, each of the extractions was measured the absorbance using UV spectrophotometer. Second parameter is determination the presence of carotenoid in pandan leaf. In this method, we use thin layer chromatography. Third parameter is thermal stability of chlorophyll pigments. To achieve this parameter, the extractions of the chlorophyll by using acetones was put into the ovens at different temperature, which is 50, 60, 70, 80, 90, and 100 degrees Celsius. After the extractions was bring out from the ovens, the observance of the extractions was measured using the UV spectrophotometer. Next is chapter 4, results and discussion. These results show the absorbance value of chlorophyll when extracted using different types of solvent. If we look at the graph, chlorophyll A has higher absorbance value than chlorophyll B when extracted by using acetone and ethanol. While the chlorophyll extracted by methanol, the chlorophyll B has higher absorbance value than chlorophyll A. Absorbance value of chlorophyll extract by acetone is the highest, followed by ethanol and methanol. This is the total chlorophyll content using different types of solvent. Based on the results, total chlorophyll content extract by acetone is 0.07 mg per gram, followed by ethanol and methanol, which is 0.004 and 0.002 mg per gram respectively. Acetone extract the highest chlorophyll of chlorophyll content compared to ethanol and methanol. The solvent to increase the chlorophyll extractions rate follows the sequence acetone, then ethanol, followed by methanol. This indicates that the lower polarity solvents achieve the higher extraction rate because chlorophyll is hydrophobic. Next is thin layer chromatography to detect the presence of carotenoid. The figure shows the silica gel coated with aluminium. Based on the results, B-carotene and lutein were detected at thin layer chromatography. These results were similar to Ningrum et al. 2015, which is B-carotene and lutein were found as major carotenoid in pandan leaf. The top band of pigment in the separations are chlorophyll B and followed by B-carotene. The table shows the RF value of pigment on TLC. Based on the results, the chlorophyll pigment have greater travel distance followed by B-carotene and lutein. Chlorophyll B and B-carotene pull with the solvents further up. This shows that both pigments are easily soluble in the solvents. Things that makes a good food coloring, must be dissolved by Rohit Bryan 2015. Non-polar compounds move up the plate the fastest, indicate the greater RF value. So in this case, B-carotene is non-polar compound because it is richly pigmented and very lipophilic. The graph shows the changes in absorbance of chlorophyll A and B during heating at different temperatures. Based on the graph, the absorbance value of chlorophyll A decreased rapidly than chlorophyll B. This indicates that chlorophyll A degrades faster than chlorophyll B as a temperature increase. The results were similar to Ursh et al. 2018, which is the ratio of chlorophyll A to chlorophyll B decreased with increasing of temperature. Chlorophyll A thermally less stable than chlorophyll B. The graph shows the changes in chlorophyll content of pandan extraction during heating at different temperatures. Based on the results above, the higher the treatment temperature, the lower the chlorophyll content. The extent heat treatment accelerates decomposition of chlorophyll in the pandan leaf sample. Based on the results, we can see that the highest chlorophyll content is at 60 degrees Celsius, which is 0.090 milligram per gram of chlorophyll content. At this temperature, the chlorophyllase enzymes is present, and the green color of chlorophyll in food colorant can be preserved by maintaining the chlorophyll structure. So the presence of chlorophyllase causes the conversion of chlorophyll to chlorophyllite, which is function to preserve the green color. Last part is Chapter 5, Conclusion and Recommendation. As a conclusion, the total of chlorophyll content was found to be highest when extracted using acetone. Besides, there are presence of carotenoid in pandan leaf, which is beta-carotene and lutein. On top of that, the chlorophyll content is stable at 60 degrees Celsius, which is the green color can be maintained. Uh, Based on the study, chlorophyll sourced from matured pandan leaf has higher potential as a natural food colorant. As for future research, experiments should be conducted at varying duration of time at different temperature in order to select the best temperature at the best time for the thermal stability method. Next, investigating other methods that affect the stability of chlorophyll in pandan leaf extracts such as pH and acidic conditions. The last one is to get more accurate results. HPLC can be used in order to detect the amount of chlorophyll and carotenoid content. This is the reference that I use in this presentation. That's all from me. Thank you for watching my videos.